Now that we've covered the physical geometry of mass, energy and matter, and how its Tetryonic geometry gives us comparisons to special relativity's mathematical interpretations, we can now advance on to the quantum electrodynamic section, which is where special relativity was specifically developed, i.e. with moving charges, current and or the conductor and moving magnet problem. As we've shown with 0-point fields or bosons, they are all equilateral geometries made up of electric and magnetic fields, and they come in either positive or negative charge quanta. These quanta add to create the charged fascia of all matter geometries, and their energy momenta content per second gives us the mass of the matter geometries. Where we put energy into a field and then separate the fields, we create an electromotive force, or an EMF. Obviously the energy momenta per charge geometry of the separated dipoles is measured as a voltage in electrical terms, and the two separated charges with their associated energy momenta or voltage has the potential to do work in an electric circuit. As we discussed in the matter side of special relativity, charges themselves can generate charged fields in their electrostatic fields, and the energy momenta in these fields creates a force of interaction between the charges themselves. It's the divergent and convergent energy momenta within these fields that creates the force of motion on charged particles that enter the field. And likewise, when we develop voltages in separated charges, either within generators or batteries, for example, and connect those separated charges with a conductor, under the second law of Tetryonics, electrical energy will flow from one pole to the other, or one charge to the other, as the energy seeks to equalize itself under the second law of Tetryonics. Once this electrical energy is in the circuit, any charged particles within the circuit or within the conductor will experience forces due to the energy momenta of the charged dipoles. In time, the energy momenta will create a current, which is the flow of charged particles in one direction or the other, determined by the dipole arrangement of the power source or the battery. These energy momenta within the charged geometry form the basics of electrodynamics and electricity in modern physics. And it's by utilizing the energy momenta within these charged geometries that we've created our modern technological civilization, where we input energy and store it as energy momenta within a charged geometry, and then release it or transfer it to a remote place via a conductive path and allow it to do work at that remote spot. This is known to us these days as electricity. In fact, there's not a great deal of difference between classical quantum electrodynamics and Tetryonic dynamics as far as the charges and the formulation go. Again, just like classical mechanics or physics and Tetryonics, the mathematical formulations are all more or less identical, except for where the math has erred through extrapolation or application where it was not appropriate. Again, the geometry of the equilateral energy momenta gives us the energy, and this is what we'll plot here. Obviously, in the case of separated charges and the energy momenta between them, we describe them as voltages, or as a potential difference, an EMF. We can then connect these two different or separated EMFs or voltage sources via a conductive wire, and the energy momenta in the charge geometries will seek to equalize, i.e. they will spread out from their charge geometry along the conductor to reach a state of equilibrium. And as illustrated in the central picture, what happens is the conductor itself becomes electrified with electrical energy. In this case, we're obviously describing the positive and negative energy momenta. In the case of a positive dipole, or a positive charge source, we have divergent positive charges. In the case of a negative, we have divergent negative charges. But when electrical energy flows in a circuit, or the circuit is completed, the conductor itself is awash with positive and negative energy momenta. And once this circuit is established, any charged particles in the circuit, be they free electrons or ions, will have energy, or will have a force exerted on them by the energy momenta in accordance with their net matter geometries, or net charge geometries of the matter. Obviously, this force will transfer energy into their chem fields, energy momenta, and determined by their inertial masses of their charged geometries, or the energy momenta within their charged geometries or charged fascia, the particles themselves will begin to accelerate, and they'll move in whatever direction according to their net charges in relation to the arrangement of the dipole of the electric circuit. Again, if we reverse this positive and negative, you would have a reverse direction of energy momenta in the electrical energy. The flow of charged particles after a given amount of time obviously lags the establishment of the electricity in the circuit, but after a while the energy is transferred from the electrified conductor into the chem fields of the particles, and they too begin to accelerate. Because they have an inertial mass matter geometry, obviously the amount of energy that's transferred into their chem fields will determine their velocity, and because they have vastly greater numbers of quanta within their charge geometries, they will have a slower velocity than the electricity itself. In fact, the electricity itself flows almost instantaneously in the circuit upon its completion, and this current, as I mentioned, will lag behind it, given by the fact that there is a finite time that is required to develop energy momenta within the chem fields to accelerate the charged particles, and the fact that the charged particles themselves have increased inertial masses. The energy itself is obviously the voltage of the circuit, and as we increase the energy momenta per charged geometry or per pole, we increase the voltage, which of course can increase the force on these charged particles. The measurement of the number of charged particles, be they positive or negative or ions, per second moving past a point in the circuit is what we term current. There can be a electron flow, or it can be conventional current, as in ion flow. Worth noting is the fact that because of the time lag and the relationship between mass, F equals ma, mass, force and acceleration or velocity of the particle over time, the velocity of the electrons or the ions is considerably less than the propagation velocity of the energy. Again, in both cases, the chem fields and the voltage fields, the velocity that can be produced is given by the simple formula E equals mv squared. But because there is no mass matter particles to move, it is pure two-dimensional energy, the electrical or the electricity part of the circuit propagates extremely fast, whereas the inertial mass matter of the ions and the electrons moves at a much slower velocity, commonly termed the drift velocity, around the speed of a person walking, and again dependent on the voltage that's applied to the circuit. Here's an illustration showing the chem fields of the electrons. As the electron, as the circuit's energized, the electron's accelerated. Again, the chem field determines the voltage, the velocity of the charged particle, the electron, as it moves around the circuit, and again, the energy momenta, divergent and convergent, for positive and negative charge plates, determines the direction of the electron flow. As the voltage increases, or the total energy momenta that's available per volt increases, the electron drift velocity will also increase as a result of energy being added to its chem field. Of course, again, special relativity, there is no change in the geometry of the electron's mass matter. What changes is the energy momenta content of its chem field, and of course its magnetic moment, which wasn't there when it was stationary due to its neutralized magnetic dipoles in the charged geometry, suddenly appears as energy is added to its chem field. So an electrostatic charged particle has no magnetic moment. A particle that has in a field that produces energy in its chem field will create a magnetic moment. There is no distortion of the geometry of the particle itself. Of course, we can relate the kinetic energy of the particle to its chem field and its magnetic moment. Both the chem field and the magnetic moment and the kinetic energy of the chem field have energies of a half mv squared, and we can express this as half the matter by the velocity squared, or the electron's motion, drift velocity. Or we can express it in terms of the energy momenta, the mass momentum of the chem field, where we take the energy momenta of the chem field, which is a square number, and we divide it by 2 to give us either the longitudinal magnetic moment, the longitudinal kinetic energies, or the transverse magnetic moment for the electron. Of course, where we have a positive charge and a negative charge, any free electrons will naturally migrate from one to the other because of the charges themselves, as well as the voltages in the circuit. And we can use the mass matter geometries of the electron plus the kinetic or the chem field energies to give us a relativistic formula for relativistic mass energy content of the system in motion. Again, the charge is invariant because chem fields are neutral charges, being two-dimensional EM fields, whereas matter has a net charge as the result of its charged fascia. Obviously, in the case of chem fields, we add energy and release energy from the chem field through bosons. In this case, we've indicated a single boson quanta, or a Planck's quantum. But again, as per normal Tetryonics, odd-numbered quanta, or bosons, transverse bosons, add up to give us scalar square energy EM fields, half of the energy of which goes into making the kinetic energy of the particle, and the other half gives us the magnetic moment. Of course, the square root of the scalar energy again gives us the linear momentum that's created from the mass velocity, or more appropriately from the mass matter velocity, normally termed matter velocity when we're referring to kinetic energies, capital M, although you still can refer to it as mass matter velocity. They are one and the same. Obviously, we can relate in terms of electromagnetic force or voltage through Newton's formulation. Force equals mass by acceleration, F equals ma. And we can determine, using acceleration as change in velocity, and velocity is a measure of motion or distance per unit of time, we can calculate the velocity created by a force on a given mass-matter arrangement using Tetryonic geometries. And again, we only use the spherical geometry to indicate that it's a point particle and it's a net negative charge versus a net positive. And in both cases, energy momenta in their chem fields result in magnetic moments reflective of their net charge geometries. Electrons will have a south-north, positive ions will be a north-south. Of course, when you change the direction of electrons, it changes the magnetic field that they produce in the conductor. And this can be achieved by usually either swapping the polarity of the battery or the voltage source in the circuit. Well, then again, you can redirect them using diodes, etc. Or in fact, block their flow completely with a capacitor. Bearing in mind that in the case of electrons, they are a storage of energy. So in DC currents, they flow in one direction as a result of the energy momenta of the electrical field in the conductor. In alternating current, where the dipole is reversed from one direction to the other, the electron itself must build up energy momentum to create the magnetic dipole. It must then stop and reverse direction. So obviously energy is being applied, stopped and reversed in a sine wave fashion, and accordingly the energy must be added and released in a sine wave fashion as well. This is discussed in other lectures. Particularly photons and EM waves has a much more detailed explanation of the use of oscillating charges to create transverse EM waves. But in both cases, all you're doing is adding energy from the electrical field in the conductor, which propagates near instantaneously to the chem field over time, which will then create a resultant velocity for the charged particle. Again, that velocity will be determinate on the force or the voltage of the energy momenta in the electrical field and the mass matter or the inertial mass of the matter geometry that's being accelerated for the current. Another way of looking at this exchange of energy to create transverse EM waves, etc., is simply that we're releasing bosons of energy. Any change in velocity requires a boson to be added or released from the chem field geometry. Again, they're all odd numbers and all transverse geometries. When they're released, obviously they can recombine, which they will do naturally through the weak force, to create photons of energy. And we can see this as spectral lines or as transverse or longitudinal EM waves. Again, note the distinction between odd-numbered bosons and even-numbered photons. They are distinctly different geometries, although they can have the same mass energy contents. Of course, we can use Tetryonics to look at the coulombic forces and how they're created through the energy momenta, as opposed to trying to explain them in relativistic terms as a change in the coordinate system or change in the relative motion of charged particles and the coordinate systems used to measure them. None of this is happening, as we've discussed. There is no distortion of charges. There is no changing view of the electrical magnetic fields. In relativity, it's commonly expressed that the electric field is a magnetic field in a different frame of reference, and vice versa. The magnetic is a electric field in a differing frame of reference. In fact, Tetryonics does away with all this and takes us back to classical Galilean or Newtonian formulation for velocities, including the velocity addition formula, because we have now shown that there is no limit to c, so therefore the energy, even though it increases at 2n-1 or odd-numbered bosons per quantum level for velocity changes, does in fact have no limit of c. So at just before C, the quantum level before C would obviously be c squared minus 1. The velocity to go past C will be c squared plus 1. And as you increase the energy momenta, the wavelength frequency relationship will give you a velocity of the particle in accordance with Newton's second law, again, F equals ma. So given sufficient energy momenta within any unit of time or charge geometry for the chem field, you will create a corresponding velocity, again matching with the inertial mass matter of the particle concerned. So sufficient energy, you will exceed c. And in fact we'll show this the case in numerous other lectures. We won't dwell on it here. But in this case what we're showing is that the energy momenta of particles in motion can be mapped using Tetryonics, and that the electric field, or that the kinetic fields, are made up of magnetic moments and kinetic energy, and equally they are electric fields and magnetic dipoles made up of Planck energy momenta. These equilateral geometries of electric and magnetic fields within the chem field give us Lorentz's force, as in attraction, the magnetic field attractions or repulsions between charged particles in motion in Ampere's law, or charged particles in conductors. Change the direction of the particle, you change the force of you change the attraction or repulsion between the magnetic poles of the chem fields, change the velocity, you increase the strength of the magnetic dipoles along with the kinetic energy and the linear momentum, and in doing so you change the force between the two particles that each particle experiences. And again, in accordance with Newton's laws, each particle exerts a force on the other and each experiences a force from the other. Relativity, as it's currently formulated and explained as a frame of reference, and the motion within those frames of references to account for magnetic and electric fields, is now completely dismissed in favour of equilateral energy momenta, divergent and convergent within specific magnetic and electric field geometries. Of course, we can also explain the attraction between positive and negative particles, or net matter geometries. And this, of course, also explains how neutral particles, such as neutrons and antineutrons, can be attracted to positive particles, just like electrons are. Again, the attraction between a neutral particle and a positive particle is due to its charged fascia. These charged fascia will create EM fields and magnetic moments for the particles themselves, and even if they're stationary, they will still contain their respective charged geometries. And in fact, it's their charged geometries, or the E fields of their constituent quarks, that creates the residual E field force, or the residual EM force as it's termed, to bring nuclei together within both the proton-neutron binding and the deuterium binding to form all chemical elements. Finally, on this page we can also show that the strength of the electric force, or Coulomb's constant, can be determined and calculated, and in fact drawn, represented by the divergent and convergent energy momenta in the two-dimensional field. Again, this kinetic energy is undetectable as a field because it's neutral. One side is positive, the opposite side is negative, using Lorentz transformations or physical changes of frames of reference. But in both cases we still have divergent and convergent energy momenta within the field, and the permittivity of the electric permittivity of these fields is a inverse squared force, and where we superposition the fields between two particles, we create a measurable force. Again, the energy squared will give us this force, and the diamond shape again tells us in Tetryonic geometry that it's an inverse squared force. Again, as we've discussed, the dipole, the magnetic moment, will have an inverse cubed force as a relationship of its strength to the distance from the particle. The poles, a single pole will be an inverse square. Dipole, inverse cubed. We can obviously simply represent all chem fields without their particles, if we so choose, as negative EM fields. In this case, we have a negative top left-hand corner, we have a negative charge particle, or negative chem field of a negative charge particle moving up off the page. Beside that, we have a negative chem field moving down. So it shows us that at its foundational level, the geometry, the equilateral geometry of Tetryonics can model everything that we currently model using left and right hand rules and advanced mathematics within relativity itself. They form natural pointing vectors, obviously, with the square of the energy field being the linear momentum, the apex of the E field in the direction that it's moving. And again, the energy content, energy momentum content, will give us a velocity in relation to the square of the field, the quanta of the field. But in this case, we're mapping, using it purely to map the direction of specific charge particles in motion. We can see positive and negative charges here, so we can obviously map similar and dissimilar charges and their directions of motion to each other. You can see the relationship here with Ampere's force laws for charges in motion in a conductor, and you can see a traditional drawing to the right hand side of the same thing, again using lines of force as expressed by Faraday and Ampere, and comparing it to the chem field magnetic moments of Tetryonic particles in motion. Again, note that the charge does not change, it's invariant to velocity, as is the mass of the matter geometry. What does change is the energy momentum content and the wavelength of quanta within the chem field in proportion to the velocity. Accordingly, all these things can be expressed using left and right hand rules, as I've previously mentioned, but Tetryonics gives us the same answers, whether we do it as a detailed Tetryonic diagram of Ampere's laws and all the possible interactions, or whether we reduce it to very simple equilateral geometries of EM fields. We can obviously apply all this knowledge to electromagnetic waves themselves, as we've done in previous lectures, or to light itself. The only difference between light in its various forms is whether it's a transverse or a longitudinal wave. Again, this is discussed in greater details, but in both cases we can see Lorentz's formula being naturally expressed. We can see the relationship between frequency and wavelength. We can in fact see quantum levels and photon probability distributions, all within the equilateral geometry of Tetryonics for QED. And likewise, simply by splitting this electromagnetic wave in half, we have two chem fields, one positive and one negative. And all the wave function properties of EM waves also apply to chem waves. And it's these properties that will give us a clear and stark contrast between relativity and the power of Tetryonics and its geometry. Obviously, the greatest hurdle at the moment, so far as electrodynamics, is understanding wave-particle duality and the probabilistic nature of photons and EM waves, along with that of de Broglie wavelengths and matter. Obviously, over time, we've advanced from Planck's heat law, where Planck determined that all energy was quantized, in stark difference to Young's formulation, where it was seen as a wave geometry. And again, this agreed closely with Newton's interpretation of corpuscles of light. Einstein came along looking at the photoelectric effect as opposed to the heat and spectral line emissions. He formulated energy as Planck frequencies or photons of light, again showing a quantized nature to wave particles, or to waves themselves, specifically as light. But Tetryonics shows us the difference between bosons and photons in terms of geometry, whereas up until now mathematics has in fact, in many cases, textbooks shown NH nu to be equivalent to NHF, when in fact we've shown now that it is not. 1 does not equal 2. Of course, as we developed in the last century, de Broglie developed his thesis on wavelengths as a relationship to the energy momenta of matter itself and of waves in general. And of course, Heisenberg came up with his uncertainty principle, and Schrodinger's wave equation came into play for the probabilistic nature of particles themselves. This all adds to the confusion. Without the geometry of equilateral energy momenta, you're left with the mathematics. And the mathematics, although starting off as describing physical systems, in fact have now been extrapolated beyond that point in an attempt to determine a finer detail or level of physics behind them. Without the physical rigidity of the geometry, they are now drawing incorrect conclusions. And this has left us with a situation of a lot of scientists spending their time on speculative ventures, on a lot of money being inserted into investigations on properties of light and properties of matter, where there is no physical basis to it. It is purely an investigation of the mathematical possibilities that present themselves. And in deference to Maxwell, I will go with what he said and what he insisted upon throughout his short career, although exemplary career so far as mathematics is concerned. He was always of the belief that where you formulate something mathematically, you should be able to build a physical model, not just explain it geometrically, but build a physical model of what the math is describing in order for it to be considered complete and accurate. Without that physical model, he always considered it to be inaccurate. Unfortunately, after uniting electric and magnetic fields in his laws, he passed away, but not before expressing this exact view. And it's a view that Tetryonics takes wholeheartedly and advances as we now get rid of and completely demolish special relativity. Obviously, we've now shown that in the terms of Planck's heat law and the photoelectric effect, photons are, or electromagnetic waves, have quantized energy momenta. These energy momenta can be measured in terms of either transverse bosons or longitudinal photons. They are exactly the same mass energies within the same field. What varies is the measurement of the physical system. And again, this produces differing geometries and differing physical properties. It's the geometry that determines the physical properties and shows us where the mathematics has gone wrong. In this case, we're giving an exact example where the mass energy momentum of a photon and a neutral Z boson are measured within the same wave, and they produce exactly the same mass energy momenta, electric permittivity and magnetic permeability as each other. Where they do differ is in their wavelengths and their charge geometry, and this is where Tetryonics excels. We can obviously show photons of energy not to be little round balls of matter, but in fact to be true two-dimensional Euclidean fields of electric and magnetic energy momenta. Again, the square root of 2 pi gives us the divergent linear momenta of the photon, and we can see its permittivity and permeability. And in the case of photons, which are positive and negative charge boson sets, we can see that they have a neutralized kinetic field, kinetic energy field, and a strengthened photon or Evans photomagneton, or a magnetic moment, as a result of these charged geometries. We can also see the linear relationship for Lorenz's correction for velocity, along with the same relationship for the scalar energy. So we can see the momenta, and we can see the scalar energy of the field. Take the energy in a measurement per unit of time, we have the mass energy of the field along with its momentum. We can also, using Tetryonic geometries, show the quantized angular momentum of the system, and we can use that to show the physical geometries of photons and EM waves, or we can use it to give us the direction of energy flux or modelled energy flux within the photons. Again, photons are unique. They do follow the general formula of E equals mv squared, as shown here. They can be considered to be purely kinetic energy systems because the geometry of positive and negative charge bosons gives you the same geometry for a photon as you would have for a kinetic energy field within a chem field. If you look closely at the geometries, you'll see photon geometries match the chem energies. Again, even though you can express them as kinetic energy, you could also express them as a chem field. The true formulation between classical and quantized mathematics or mass energies is, of course, mass velocity squared. Again, mass because they're two-dimensional energy fields. And the quantizing of the energy geometry gives us squared number Planck quanta. And in fact, it will give us 2 Planck nu squared, because there's 2 charges involved here. Each equilateral geometry being a square, and each square geometry giving us a vector linear momentum in a specific direction. So 2 masses. Everything about it from the geometric perspective shows us that photons are 2 pi geometries. Again, because they couple via the inductive force or the weak force, via their inductive bases, they go from the 2, let me explain this right, the 2 quantum inductive geometries, the equilateral geometries of bosons, which are unidirectional rotations of energy, can be modelled as I think it's pronounced lemskate or something to that effect, a infinity symbol, which is the flow of energy in a one-to-one transformer coupling. 2 inductive fields inductively coupled together form a transformer coupling. In this case, both fields are identical strengths, so the energy will flow from positive to negative, negative to positive in a continuous basis, or we can be modelled as doing that. In fact, there is no physical flux of energy. The properties are in fact the result of the equilateral geometries. It's often stated that when Einstein started to formulate relativity, he often wondered what it would be like if you could catch up to a photon of light, what you would see. Relativity, as it was formulated, suggested that the photon would move away at the speed of light due to different frames of reference. However, in this case, we can clearly see the geometry of the photon, and we can clearly see both its electric and magnetic field properties as a result of being the result of its geometry. It is not the result of a change of frame of reference as expressed in special relativity. And again, you can see the relationships between the frequency of the photons within the EM wave and the wavelength that the photons will have as we increase the energy of any EM wave. Again, the EM wave will be a specific geometry, and as we increase the energy, the quantum number will increase. Therefore, the photons must compress in length in order to fit into the geometry. All of these features, along with the transverse boson levels and the longitudinal photon measurements of the EM fields, as well as the linear momentum of the system, its amplitude in relation to each other, and their relationship to the scalar energies, can be determined and drawn as the wave function of any EM field using Tetryonic geometry. And all these relationships, wavelength, frequency, linear momentum, charge, energy, momenta, all the relationships can be related to each other through velocity and alpha, as in the equilateral geometry of energy itself. This relationship of alpha is easily expressed here in terms of electromagnetic waves or photons themselves, where the EM wave is comprised of photons. You can see the charge arrangement that leads to positive charge fields on the right hand side and negative charge field on the left, just like the photons individual charges are. And if you count all the positive and negative charge E fields and the north and south dipoles, you'll see that they do in fact neutralize out within the EM field itself. But looking closely at the kinetic energy formula for mass energy or quantized mass energy, mv squared equals energy equals h nu squared per c squared, we can in fact not only draw, but we can determine all the relationships of wavelength and frequency as a measurement of alpha. Where we look at de Broglie's wavelength formulation, we know that Planck divided by c will give us the wavelength for EM waves. Of course, Planck's constant is just a measure of mass by quantized angular momentum, or the geometry of energy. So we can strip the mass out and ignore it and just look at alpha per c, which we can do here, to give us wavelength. Do the algebra and you'll see that it in fact gives us meters. Likewise, we can do, that's a linear measurement obviously. Likewise, we can do the same thing with a scalar measurement of the equilateral energy within a field, in this case c squared being the scalar field, and we're dividing it by the equilateral energy geometries, or just the geometry of energy. Again, square meters per second squared for c squared divided by or multiplied by the inverse of quantized angular momentum, seconds per square meter, gives us the answer of per second, or frequency. So per seconds, meters, combine the two when we do the cross product of wavelength and frequency, as we've done on the center here. We multiply frequency by wavelength and we get a measure of meters per second, or a velocity. In this case, obviously, it's the natural velocity of energy, which is c. So we can show through Tetryonic geometry and alpha that the natural velocity of energy, or the speed of light, the velocity of light, is in fact the result of the equilateral geometry of its scalar and linear measurement of energy, or its frequency and wavelength. Of course, having calculated wavelength, we can invert it and do c divided by a, or velocity divided by the equilateral geometry, and that'll give us per meter, or how many equilateral geometries for bosons per meter are in there, and that is the wave number, just the inverse of wavelength. But all these relationships that have normally been expressed as just velocity equals frequency by wavelength for any medium within Tetryonics and classical mechanics, physics, can now be shown at a greater detail to be simply the relationship of equilateral energy geometries to either the linear properties, physical properties, or the scalar energy properties of EM waves. Obviously, we can apply these same things to any charged matter in motion. And in doing so, we convert the standard formulation for E equals mv squared, which is a little bit hard to see here, to, in the case of electromagnetic waves, E equals mc squared, because it propagates at the natural velocity of energy, which is c. And coincidentally, energy circulating within matter geometries also circulates at the natural velocity of energy. So if you were to release the energy within matter, you could do an equivalency between the energy and mass itself, and you would come up with E equals mc squared. The energy, the mass energy content of matter, is already propagating at c. In the case of electromagnetic waves, again, the wave is already propagating at c, the energy of the wave, because of its frequency wavelength relationship. The only time this changes is when we have kinetic energy fields. The energy of the field, the energy momenta in the chem field, obviously can only accelerate the inertial mass matter to a certain velocity dependent on the total or the physical mass matter of that particle, F equals ma. So accordingly, the equation here should be E equals mv squared, or half mv squared for the kinetic energy or the magnetic moment. Again, the same relationship, and this hints and confirms that in physics, as illustrated through Tetryonics, it is much better to refer to the natural speed of energy, or the speed of light, as v, particularly in relationship to wavelength frequency, rather than c, because E equals mc squared only applies in the case of electromagnetic waves or photons, or in energy released, or energy released from standing wave matter, where you specifically want to equate energy to matter. There are examples where E equals mv squared is more appropriate, as in the case of matter in motion. And again, it's the wavelength of the chem field that changes, not the wavelengths or the de Broglie wavelengths of the matter itself. And this is what we've done here. We have simply stated, instead of c, that it is the velocity of light. C just adds a layer of confusion, and it hints that the mathematics is now driving, or extrapolation of the mathematics is driving new discoveries, rather than an understanding of what is physically going on at the quantum level. Again, Tetryonics gives us all the mass velocity and quantized energy relationships for energy momenta within any equilateral geometry. And we can use this relationship of equilateral energy and its geometries between scalar and linear measurements, transverse and longitudinal measurements, to give us all the familiar laws of Newton, Maxwell, Planck, Einstein, etc., as well as our physical relationships and physical units of energy and wavelength, etc. Obviously, in the case now that we have the geometry of a photon firmly established, or an EM wave, we can set up a detector and model what happens when an EM wave or a photon moves across a photodetector circuit, or interacts with matter or a detector. In this case, we just have an imaginary line. But as the EM wave or photon propagates towards the detector, you can begin the measurements. You start at 0, you progress to a maximum positive E field, then as the E field starts to diminish, the M field begins to ramp up till it reaches a maximum as well. Obviously, you have to take into account that there's a north and a south with the E field, with the M field, sorry. This one's just indicating one side, but in fact you could just draw it as a magnetic sine wave. When the magnetic field is at its maximum, the E field is at its minimum. Then as the M field, magnetic field, starts to drop down as it progresses, the negative E field ramps up. And again it will reach a maximum, indicated by the geometry of the E field permittivity. And then as it progresses, that E field will drop back down. In this case, there's a ramping up magnetic field, and that will be created by any photon within the EM wave that is lateral to this photon. The M fields of the lateral photons will be increasing, and in fact you can see this when you look at the geometry of photons within EM fields. There is a 90-degree sine-cosine relationship between electric and magnetic fields within the linear photons, the longitudinal measurements, and there is a 90-degree phase relationship between the E fields of laterally, or more appropriately between the EM fields of laterally displaced photons within EM fields. Again, these are all things that couldn't be explained using relativity. Of course, we can now look closely at energy changes, or energy momenta changes within chem fields, as we've done in previous lectures, and using matter velocity squared for the energy or the quanta within chem fields. Obviously, whether you're talking matter velocity or Planck's constant mu squared, they're directly proportional to each other. With chem fields, in Tetryonics, I tend to indicate the quanta in a blue colour to reflect that it's a neutral field. It may have the distinct magnetic dipole, but the kinetic energy, like a photon, is a neutral energy geometry. It's the magnetic dipole that determines the charge of any EM field. So by knowing the velocity, we know that the energy momenta quanta will be, in fact, the square of the velocity for the particle, because of the relationship of its mass matter to the force. As we transition, we obviously affect the linear momenta of the system, because the square root will vary to the square root of the energy quanta within the field. So with less energy quanta, you'll have less force, because there are less quanta within the field to produce a force, and accordingly with more quanta there will be more force. And this is what happens within electrons bound to elements. There's an entire lecture on spectral lines and on the photoelectric effect that you can go through and read, which will give you much more detail on this particular process and the mathematics. But needless to say, this geometry again gives us the fractional energy field transitions or changes for the photoelectric effect. Again, mathematically expressed as Rydberg's formula. A mathematical formula that's never been fully explained as to how it... They know how it works, they don't know the physical reason why it works through the formulation. Again, the lectures on photoelectric effect and spectral lines explain this exact mechanism, again explaining geometrically what has been done mathematically. Of course, for special relativity we have to apply it to the photoelectric effect. And in this case we can see that as we add energy to incident photons, we change their frequency and the wavelength of the energy momenta within the EM fields themselves. Higher energy fields have shorter wavelengths. In order to increase the energy levels from one squared energy level to another to excite electrons out from sodium, we need to increase the energy momenta through the addition or release of bosons, odd-numbered geometry, transverse geometries within the chem field. Again, these geometries have specific, these energy momenta have specific geometries. You cannot increase from a N5 energy level to a N6 by adding 9 or a green color. You specifically need to add a blue color or a higher energy. Again, it's a specific energy at a specific frequency to give you the squared energy levels. Again, these reflect energy levels, not mass. In this case, they're reflective of the mass wavelength relationship. These, because they're all within the same geometry, are reflective of the mass energies. As we change the energy content of this same field, we of course change the wavelengths, the frequency and the wavelength of the quanta within the field and its linear momentum. And that is what Rydberg's constant is all about. Rydberg's constant is simply a re-expression of the linear momentum, or the square root of the energy momentum in chem fields. We can then apply Tetryonic geometry not only to elements themselves to give us the charge geometry of sodium and its energy levels, but we can also apply it to show us what the transitions and the frequency and wavelength of the photons, what are required to break electrons, to excite electrons and break them free of the elemental nuclei. We can also show, as per QED and quantum chemistry, that there are more electrons to be gained by accelerating N2 to N4 or higher electron levels, chem levels, than there are accelerating either energy level N1 or N3 electrons. There are in fact 4 times as many N2 compared to N1, and 8 times more N2 compared to N3 energy electrons. So while it might be easier to break N3 electrons away from the nucleus, in fact you will get more electrons for your current by increasing the energy levels of N2 to N4. It will be a more efficient process. Of course, again, just like energy itself and all the relationships, we can show all the relationships for photoelectrons and the photoelectric effect with equilateral geometries, where we show the matter geometries distinct from the chem field mass energy geometries. But they are all related through the equilateral geometry of mass energy, or Planck's constant. Using this geometry, we can explain all the spectral lines. We can explain the production of transverse and longitudinal waveforms and the differences between the two. In doing so, we actually bring Tesla's longitudinal energy fields back into play within physics, and we explain the Hertzian-Maxwell formulation for transverse waves and how they differ from Tesla's longitudinal waves. But of course, in doing all this and giving geometries to mass energy fields, we also completely undermine the relativistic notion of changes of frames of reference being responsible for electric and magnetic fields. Of course, this also impacts so far as explaining quantum mechanics in terms of relativity, and it has a big impact in explaining what is a wave geometry and what is a particle. In Tetryonics, waves and photons are two-dimensional Euclidean mass energies. Particles, for the larger part, refer to three-dimensional standing wave matter geometries, i.e. matter itself or fermions. We can use the basic geometry of EM waves to give us a simple analogy for algebra. Positive plus negative fields, A plus B, as far as charge geometries, frequency by wavelength, gives us velocity with respect to C, and the velocity of energy is obviously equal to the speed of light, which gives us Lorentz's correction factor for velocity. In the case of photons and standing wave matter, the velocity is c. In the case of chem fields, the velocity is determined by the inertial mass matter of the particle that's being accelerated, and you won't have this A plus B situation. But again, just illustrating that the geometry can give us the mathematics. And in all cases, whether we're measuring boson distributions, transverse mass energy measurements, or longitudinal photon mass energies, they produce normal distributions or bell curves of energy, and the quanta and displacement of energy, equilateral mass energies within these EM fields can be renormalized. The amplitude will give us the probabilities of finding quanta as it deviates from the mean, and these probabilities can all be added back up again to give us a renormalization of 1, again in line with QED. But in this case, unlike QED, we do not have any infinities, so there's no need to cancel infinities out. Tetryonics works on equilateral or finite equilateral geometries and fixed integer quanta, just as quantum mechanics should. There is no need to mathematically resort to infinities to calculate a probability or to determine the wave function of EM fields or EM waves, chem fields, etc., or de Broglie wavelengths of mass matter. And as I've just said, the EM waves themselves, as far as their energy momenta and their charges can be drawn, we can then redraw them as boson transverse energy fields, or as the wave probabilities of longitudinal photons within the EM wave itself. Again, noting that 2 Planck quanta or 2 bosons equal a photon. Again, they're the same energy, whether you term it as energy within an EM wave or the total wave as a kinetic energy field. Makes no difference. Mathematically, you can't distinguish between them. Geometrically, you can. Just as geometrically, you can distinguish between the wave geometries and properties of longitudinal photons and transverse bosons. You can take either waveform as a measurement and relate it back to the total energy momenta of the EM wave. Again, with the electric and magnetic properties being the result of the geometry, not the frame of reference of the observer. All of QED can now be explained, along with photoelectric effect and Lorentz corrections, in terms of quantum distributions of equilateral mass energies within EM waves, or within the photons that constitute, photons and bosons, that constitute electromagnetic waves. This then gives us a firm definition of electromagnetic waves as 2-dimensional EM fields of mass energies that can be measured longitudinally or transversely, whose amplitudes give us the probability of finding energy geometries within that wave, whether they're bosons or photons, and whose amplitude is also related to the linear momentum of the system as well. It also shows us clearly that changing electromagnetic waves produce changing electric fields and vice versa. This absolutely undermines not only the formulation of relativity, but the ability of relativity to predict things like Tetryonics does. Tetryonics is far superior for every physical system measurement and for modeling systems of mass energy. course, all these probabilities, as we said, not only renormalize, but they create a bell curve for quantum systems through the equilateral geometry of mass, energy, momenta within fields and within matter itself. These energy distributions follow the normal distribution. They've been well known for a long time, but what is interesting is that through Tetryonics we can in fact show pi radians for the equilateral geometry for not only fields but also matter itself. We can show the square root of energy fields to be the linear momenta of the systems, and we can show the probabilistic statistical probabilities of finding particles, energy momenta quanta, within any field or particle. Obviously we can then relate all these properties back to charged geometries, and in the case of a negative charge geometry, where we would have a south-north magnetic field, the energy quanta distribution within that field can be reformulated, and in fact when you reformulate it, it will reveal Euler's formula, where the irrational square root of -1 plus the trigonometric functions of pi and exponentials all combine within one formula to in this case give -1, but it can in fact rationalize out to be 0, where we add a positive charge to e to the I, say e to the I positive, which is the mirror image of e to the I negative. Positive charge and negative charge will give us 0. So we can then reformulate this to be e to the I plus 1 equals 0, Euler's formula. Again, comparing sine and cosine, we can reformulate Euler's formula to give us the phase relationships between not only electric and magnetic fields in the longitudinal photons, but between the phases of individual photon EM fields in photons laterally displaced from the median longitudinal photon, or the amplitude. We can apply all these to both quanta and frequency, bearing in mind one's a transverse boson measurement, the other one's a longitudinal frequency measurement, photons, to give us our wave functions. And these wave functions not only apply to electromagnetic waves, they also apply to the chem fields of particles and motions, as well as the mass energy geometries of charged fascia in matter itself. And that's what we've drawn here. We can of course measure the energy of chem fields as bosons or as photons. We can do the same thing with the matter geometries. We can measure their mass energy content as transverse bosons or longitudinal photons. In either way, the relativistic energies, the mass energies of these systems is identical, and it's proportional to the rest mass matter plus the chem field energies, and it's the chem field energies whose wavelengths shorten as the velocity increases and their frequency of quanta increases. And again, they're all renormalizable. Without, this case, infinities, we just go from -n to +n, or -v to +v, depending on what you're measuring. So we've shown, so far as wave and particles are concerned, the wave, the mass energies, are in fact two-dimensional Euclidean geometries. Whether they are EM fields or photons or chem fields, they are mass energies within a charged geometry, or a voltage if you like. Accordingly, if we're referring to a particle, we are in fact referring to the standing wave geometry, the three-dimensional mass of matter, mass matter geometries. But we can measure these energy contents, mass energy contents, any way we wish, be it through quantization, bosons or photons, classical scalar measurements or quantum measurements. And that's what we're showing here. The equilateral bosons all combine to form increasing energy momenta, to form energy levels or transverse energy levels. These transverse energy levels can be measured as transverse quantum levels, or they can be measured as longitudinal photon energies. And again, we can use the amplitude of the wave as expressed here to calculate the probabilities of finding a quantum of energy momenta anywhere from the mean or the amplitude of the wave. And the relationship between the probability of finding a quanta is the square of the amplitude. Just as the energy quanta for any specific velocity is the square of the velocity, again taking into account the inertial mass of the matter geometry as well. So Tetryonics will give us a full explanation of QED and wave-particle geometries. We can of course apply all this specifically to waveforms, EM waves, etc., as we've done on this page. I'll let you have a look, but we're just repeating and redrawing in individual examples of fields where we have bosons and photons and wave function probabilities, all expressed in terms of geometry instead of mathematics. Of course, the mathematics still lines up, whether we express it as bosons or photons, or as probabilities, whether we express it as quantized energy or as scalar energies. The relationship remains the same. It's all the mathematics is derived from the equilateral geometry of Tetryonic mass energies, or mass energy momenta specifically. We can then obviously, instead of just referring to two-dimensional mass energies or waves, apply this to particles in motion, where the particle is the mass matter and the wave is the two-dimensional chem field energies. Of course, all the relativistic Lorentz contractions and corrections that we've spoken about before still apply to chem fields, and apply specifically to chem fields. They don't apply to the matter in motion, only to the chem field that is related to the mass of the velocity squared, mv squared, for particles in motion. Kinetic energy being half of that, magnetic moment being the other half. We can obviously, using Tetryonics, model both positive and negative charges and their associated energy fields, giving us a relativistic mass energy for the field, just like relativity, special relativity does. But we can in fact discern between the wave functions and the matter function, the matter of the system and its mass energies. Obviously, as we've discussed, the Lorentz contraction applies to the chem field energies alone. The matter is invariant, irrespective of its charge or its mass energy content. But all the properties that we've discussed of QED apply to the energy momenta of the chem fields. And these include things like the linear momentum changes, the wavelength, the scalar changes, or the frequency, giving us the frequency wavelength relationship to the velocity of the field. Again, relating the energy momenta, the squared number of energy momenta, to the velocity that the energy momenta can produce under F equals ma. And we can relate this back to wavelength contractions, not length contractions, unless you specify that it's referring to the length, the physical length of the energy momenta of chem fields. It's better to say wavelength contractions. And of course, time, as discussed in other lectures, is in fact a measure of the charge or the equilateral geometry, the alpha of the fields, where alpha is quantized angular momentum per c squared for charge, giving us seconds. Mass seconds is a measure of amperage, for example, or current. Seconds, kilograms is amperage, kilogram second is current. Again, all the mathematical formulations for Lorentz's corrections for velocity apply to the energy momenta in chem fields, not to the matter itself. And these numbers have no limit. They are integer numbers, but C is not a limit. If we were to supply sufficient energy levels, energy momenta to the charge geometry of the chem field, we could in fact, under F equals ma, accelerate the particle to greater than C. Again, it's just dependent on releasing sufficient energy per unit of time to provide an impulse to get the particle up to the right velocity under F equals ma. This is something that the mathematics does not show, but the geometry clearly shows. The final part that we look at, which is the nail in the coffin for relativity, special relativity, is the fact that we can now show bar magnets to in fact have equilateral energy geometries radiating out from their singularity or the block wall at the center of the magnet. Of course, as you cut the magnet in half, you're just quantizing the energy, so it will just duplicate itself as it does in real life. But because these chem fields that radiate out, the electrostatic fields, are neutralized, they're positive negative geometries, both as you view them here and back in Lorentz transformations of coordinate systems, or flipping the magnet over, you would see a negative this side and a positive on the back of the negative side. They are completely neutral. You cannot detect them using charges, but what they can do is when you move a conductor between the positive and the negative energy charges of the energy momenta of the positive and negative fields, they will create an electromotive force through the conductor, or they will provide a force on the free electrons in the conductor. As you move the conductor along the magnet, backwards and forwards, the strength of the E field will vary and the current will vary. And of course it will vary if you change the direction and use ions instead of electrons, etc., as we've discussed. But this is what's been hidden, both the geometry and the fact that there is an E field. Einstein explained this as a changing frame of reference. Either you're stationary with respect to the electron and the magnetic field is changing, or you're stationary with respect to the magnetic field and it's the changing electric field that's producing the EMF. In fact, it is neither. The geometry, any motion of a straight line above the geometry in line with the quantum harmonic motion that we've described before, will produce a changing electromagnetic field. Both the electric and the magnetic will change, and accordingly to free electrons within a conductive loop between the electric fields, an electromotive force will be created on the free electrons in the conductor, and that is what creates the force and the motion of electrons in the conductive loop. And this is what we're describing here. If you take a transverse measurement of the magnetic field, EM field, of a bar magnet, you measure the bosons, or the quantum levels of the EM field. Again, bar magnets have a EM field, an electric and a magnetic. You do not get one without the other. Where you sense just a electrostatic E field, you have a neutral magnetic field, and where you sense a magnetic field without the electric, you have a neutralized E field. In this case we have a bar magnet, so we have a neutralized E field, but there still remains a E field all the same, of a diamond geometry, with positive and negative charge fields, the energy momenta of which create an electromotive force on electrons in a conductor that move through them, that create the circuit as drawn here. Obviously another way of expressing a bar magnet then would of course be to express it as a battery, where the magnetic field is expressed and the charges are more or less short-circuited. They're of course not short-circuited because at this point of singularity, right at the center of the field, there exists a block wall in the magnet where the electric fields are zero and the magnetic fields are zero as well, which is the same thing as saying there is nothing there, or a separation of electric and magnetic fields, and that very minute quantum separation is sufficient to create separated charges in the case of E fields. Again, read this at your leisure. It's just a more detailed explanation of the moving conductor or moving magnet frames of reference as expressed in special relativity, comparing them to quantum levels and photon or longitudinal forces that are contained within the EM fields of magnetostatic fields. This is drawing the same thing out again, but this time we're emphasizing the fact that we have a positive and a negative E field. Even though it's neutralized in the case of a bar magnet or a photon, there still remains a 0 point or a singularity, and as such we still have separated charges. It's just the greater the separation, the better, so far as creating EMFs, but you need at least a separation, and this is always present in bar magnets. Again, all explained through the equilateral geometries of Tetryonic mass energies, as is the force. The stronger the magnet, the greater the EM field, so therefore the higher the number of energy momenta quanta that are in there to create a EMF in the conductor. And of course this picture isn't quite correct because we've got the loop travelling in the wrong direction. It should be up and down versus side to side, but any motion of the conductive loop through the E fields will create an electromotive force of varying energies, because you're changing the photon as well as the boson energy levels because of their geometry. So it will create a varying electric field on the electrons in the conductor. But again, this has been interpreted as a changing magnetic field because of the geometry relationships between the electric and the magnetic. It is a geometric relationship, not a change of frame of reference. So to sum this up, obviously in special relativity, it's the change of electric and magnetic fields is claimed to be a result of the changing inertial frame or frame of reference, whether you're looking at it from a moving frame or whether you're looking at it in terms, whether you're with the electric looking at the magnetic or the magnetic looking at the electric. In either case, all three of these examples have been dismissed using Tetryonic geometry, not only just within special relativity's explanations, but right through, because Tetryonics obviously applies to quantum mechanics, QED, electrodynamics itself, chemistry and cosmology. And in fact, in future lectures, we will explain quantum gravitation using Tetryonic geometry as well, and that will completely undermine and dismiss relativity as a valid theory. Of course, all the forces, EMFs as well as Lorentz forces, Ampere's law, etc., have now all been explained using Tetryonic geometries. And in this case, the Tetryonic geometry says we have chem fields, a photon being a chem field itself, or the kinetic energy, two chem fields, which is just a measure of the energy momenta within charged geometries, whether you measure them longitudinally as photons or transversely as bosons, but they have electric and magnetic properties. And as the quanta increase, the electric and magnetic properties increase in relationship to each other. They're equal at all times, and these have been mistaken as kinetic energies and magnetic moments. They are in fact two properties, the electric and the magnetic properties of chem fields. There is no relativistic distortion of matter itself. Matter is invariant to motion. What is distorted or compressed, where the Lorentz transformations apply, is the energy momenta within the chem fields themselves. And as Einstein himself said, if at first an idea is not absurd, then there is no hope for it. In this case, using equilateral or triangular mass-energy geometries, we can in fact not only explain all of QED, quantum mechanics, and chemistry, along with cosmology, we can completely reinterpret those physics, or the physics of those disciplines, in terms of the equilateral geometry, and in the same process completely disprove relativity and open the door for a greater understanding of physics and science in general at the quantum level. That ends this lecture. It's been a long one. I do appreciate you taking the time to follow it through. If you have any questions, as usual, email me directly, post it on the Google Plus or the YouTube channels, and I'll get straight back to you. We'll enter into some more mathematics in the next one, and then we'll move on to general relativity as we again seek to reinterpret gravitation in terms of equilateral geometries.